Alright guys, so we're looking at the 2021 Namibian Senior Secondary Certificate. So this was the first AS level exam that was written since we introduced this end of last year. So let's jump straight into the questions. So firstly we have your polynomial. We've got given a polynomial where m and n are constants over here. And this polynomial leaves a remainder of 45 when divided by x plus 2. Okay, so when we divide by x plus 2, let's put that equal to 0. So that means when x equals -2, then we'll have a remainder of 45. So we can do f of 40, not f of 45, f of -2 is equal to 45, because this is the remainder. If you substitute -2 in, you'll find a remainder of 45. So that's one equation. Now we can do the same with when we divide by x minus 2. So if we divide it by x minus 2, we'll get x equals 2 as the solution. So x equals 2, if we substitute that in, we have a remainder of 21. So there's our second equation. And now we can just form two equations by substituting in and then solving them simultaneously. Okay, so if we substitute x with -2, then we get 2 times -2 cubed plus m times -2 squared plus n times -2 plus 5. So substituting in -2, we get a remainder of 45. Okay, let's simplify this a little bit. So -2 cubed is -8 times 2 is -16 plus 5. Well, let's just do this like this. So -16. Here, -2 squared is 4, so that gives us 4m. -2 times n is -2n. And then plus 5 equals 45. So let's collect like terms. So that leaves us with 4m minus 2n equals. So 45, we take the 5 over, it becomes -5, so that gives us 40. And then we add 16, so that's 56. So there's our first equation simplified. Now let's do the same for this one. So we have f of 2, so we're going to substitute 2 in. So 2 times 2 cubed plus m times 2 squared plus n times 2 plus 5 equals a remainder of 21. Okay, so let's simplify this. 2 cubed is 8 times 2 is 16. 2 squared is 4. 4 times m is 4m. 2 times n is 2n. So plus 5 equals 21. So collect like terms, that's going to give us a 4m plus 2n. And then 21 minus 5 is 16. Minus 16 is 0. Okay, so there's our second equation. And now I'm going to use elimination to solve this. So I'm going to write the two equations above each other. 4m plus 2n, sorry, minus 2n for the first one. 4m minus 2n equals 56. And then below that, 4m plus 2n equals 0. So we can see here the coefficients of the m's are exactly the same. So if we subtract these two equations from each other, we will eliminate the m's, hence the term elimination. Okay, so 4m minus 4m is nothing. -2n minus 2n is going to be -4n. And then 56 minus 0 is 56. So divide both sides by -4. 56 divided by -4 is -14. So that is the value of n. And then we take any of these equations. So let's take this one and substitute back in the n. You can take either one. So in this one, we've got 4m plus 2n, and n is -14, equals 0. So that gives 4m, and then 2 times -14 is -28, equals 0. So 4m equals positive 28, and divide both sides by 4, we get m equals 7. So there is our solution. Okay, so just to recap again, if they tell us when the polynomial leaves a remainder of 45 when divided by x plus 2, so that means x plus 2 equals 0, so x equals -2. If we substitute x equals -2 into this equation, then the answer is going to be 45, because that gives the remainder when you substitute this value in. So when you substitute that value in, that gives you the remainder. So that's how you can build the two equations to simplify. Okay, let's just quickly check this front page to see what we have to round off to and that kind of thing. So if working is needed, show this. If additional space is needed, you'll get some page to do that on. Number of marks given in brackets. Non-programmable calculators may be used. If the degree of accuracy is not specified in the question and the answer is not exact, give the answer to 3 significant figures. Okay, so you have to round off to 3 significant figures if the answer is not exact, or give answers for angle sizes to 1 decimal place, but angles in radians to 3 significant figures. Okay, so 3 significant figures if it's not exact, or if it's an angle in degrees, we do 1 decimal place. Again, for pi, we just use pi, or we can use 3.142. We'll just use pi, calculator pi. All right, so that was question 1. Now question 2. Okay, so this one is from right to left. This is 1b. Solve this equation. Okay, so solving a cubic function, 6x cubed minus 5x squared minus 3x plus 2 equals 0. Okay, so to solve a cubic function, we don't have a nice equation like for quadratic where we have that negative b plus minus all square root thing over 2a. Well, there is one, but that's way too complicated and takes way too much space to write on. Even just the formulas itself will take more than this space. So we're not going to be going that route. So what we do, or what the people do with these questions, is they give you at least one integer solution to this. So they'll give you a polynomial that has at least one integer solution if we're doing cubic functions. So we do trial and error to find that first integer solution. Okay, so how do we do that? Well, we're going to test. So we just said if we substitute in some value, so let's say f of some value a, if we substitute in a and the answer to that is 0, that means that x equals, so x equals a is a solution, which means x minus a is a factor. Right, because with a remainder of 0, that means we have a factor, right? Just like, for instance, if you take 6 and you divide it by 3, you get 2 with no remainder. That means 3 is a factor of 6. Okay, I hope you understand that part. So what we're going to do now is to test which factor will give us, or which number will be a factor. We have to test some values. Which values do we test? Well, we take this value and this value. So the one in front of the x cubed and the constant, we multiply it together to get 12. And then we have to test all the factors of 12. So all the factors of 12 are 1, 2, 3, 4, 6, and 12. So those are all the numbers we can test, and the negative versions of them. So also negative 1. So let's just do plus or minus of each is what we're going to test. All right, so it might take a while to get to the answer because there's lots of options we can test. Now I'm going to start with positive 1. So if we do f of 1, what do we get? That gives us 6 times 1 cubed minus 5 times 1 squared minus 3 times 1 plus 2. And let's see what that simplifies to. So 1 cubed is 1, 6 times 1 is 6. 6. Okay, 1 squared is 1, negative 5 times 1 is negative 5. Then negative 3 times 1 is negative 3, and then plus 2. So that gives 6 minus 5 is 1, 1 minus 3 is negative 2 plus 2 is 0. Okay, so that's awesome. So that is our factor, right? Because we get a remainder of 0. So if we substitute x equals 1, that's a factor, which means that if x equals 1, then if we take it across, we get x minus 1 equals 0. So this is our first factor. Okay, so now we already know we can rewrite this as x minus 1 times something, right? Just like if you had 6, you know 3 is a factor, you can write 6 as 3 times something. And then to find what this is, what do we have to multiply through with to get to 6? Well, we can say 6 divided by 3, and then we get 2. So that's how we get the part that's remaining. We do a division. So that's exactly what we're going to do. We're going to take our original equation, so the 6x cubed minus 5x squared minus 3x plus 2, we're going to divide it by what we know is a factor, and that's x minus 1. Okay, and then we'll get our quotient on the top here. So that's what's going to be in this bracket. All right, so let's do that. So 6x cubed divided by x is going to be 6x squared times this by this whole front part. So 6x squared times x is 6x cubed. 6x squared times negative 1 is negative 6x squared. And now we're going to subtract this. So 6x cubed minus 6x cubed is nothing. negative 5x squared minus minus 6. So minus minus becomes plus. Negative 5x squared plus 6x squared is 1x squared. Okay, and then we bring down the next value, that's minus 3x. And now we just repeat the process. So again, x squared divided by x is going to be x. Then we say x times x is x squared, and x times negative 1 is negative x. So again, we're going to subtract this. So x squared minus x squared is nothing. Negative 3x minus minus, so again plus. Negative 3x plus x is negative 2x. And then we bring down the next value. So that's plus 2. And we repeat the process. So 2x, negative 2x divided by x is negative 2. Then negative 2 times x is negative 2x. Negative 2 times negative 1 is plus 2. And then again, we're going to subtract that. So negative 2x minus minus 2x is nothing. 2 minus 2 is also nothing. Okay, so that's good. We know there shouldn't be a remainder when we divide by x minus 1. That's why we did this whole test here. So this is now what's left. So we can write that in here. 6x squared plus x, let me just rewrite that. 6x squared plus x minus 2. Okay, and we're solving this equation. So this whole thing is still equal to 0. Okay, so now we know that either, so let me just rewrite that over here. So we've got x minus 1 times 6x squared plus x minus 2 equals 0. So that means either this is 0, x minus 1 equals 0, or this is 0. So 6x squared plus x minus 2 equals 0. Alright, so for this one we can just say, okay, x equals 1, so that's one solution. Or we have to set this equal to 0. Now, a couple of ways we can do that. We can factorize, or we can use our quadratic equation, or we can do completing the square. So this one can factorize. So we're going to say that whole thing is just going to be 2 brackets. So, and now we need to decide how to factorize this. So I'm actually not going to go over how to factorize a quadratic here. We should all be fine with that. So it's going to be 3x and 2x. Let me just check, because I also have to think a little bit here. It's going to be minus 1 and plus 2. That's right. Okay, so then either this equals 0, so 3x plus 2 equals 0, or this equals 0, 2x minus 1 equals 0. So this gives us 3x equals negative 2, so that gives us x equals negative 2/3. Or 2x equals 1, and that gives us x equals a half. So there is our solutions. Okay, 3 solutions. And that's also a clue. The biggest exponent, that's going to be how many solutions you have in general to a question. Okay, but just to show we didn't need to factorize, we could have also used our quadratic formula. Let's just say x equals, so negative b, so that's going to be negative 1, plus or minus the square root of b squared, so that's 1 squared, minus 4 times a times c, so a is 6, so 4 times a, and c is negative 2. All of that divided by 2 times a. Alright, so let's get the calculator out for that. Well, actually, let's do it without a calculator just to practice a bit of normal adding and subtracting. So we've got negative 1 plus or minus square root. So 1 squared is going to be 1. Minus minus is going to be plus. 4 times 6 is 24. Times 2 is 48. So 48 plus 1 is 49. 49. Oops. And divided by 2 times 6 is 12. Okay, so the one option will be negative 1 plus 7 over 12. Other one will be negative 1 minus 7 over 12. Okay, 4 times a times c. Let me just make sure everything is correct here. Okay, so negative 1 plus 7 is 6 over 12, which is a half. Or negative 8 over 12, which we can simplify to negative 2 over 3. So we see we get the same answers as we got over here. Okay, so you're welcome to just use the quadratic formula. I always give myself a general rule. If I can't do the factorizing in, let's say, 10 or 15 seconds, then I feel like I'm taking too much time with the factorizing, and then I just plug it straight into this formula. And you can also do completing a square if you're uncomfortable with the formula or with factorizing. But I would suggest completing the square is more difficult or more chances to make a mistake because it's longer. So I would suggest just factorizing, and if you're struggling, if you get stuck with the factorizing, just use your quadratic formula. All right. question 2. Okay, so for question 2, showing all necessary working, prove that the integral, let me just rewrite that, maybe you can't see it as clearly there, integral from 1 to 4 of 8 over 2x plus 1 with respect to x is equal to ln 81. Okay, we have to prove this. So basically we have to do the integration here and just show that that's equal to ln 81. Okay, so for this, let me just go over the rule again. If we're integrating 1 over x, right, with respect to x, then this is equal to ln x. Okay, so that's a rule of differentiation that we need to know. Now let's just change it up a little bit and see how can we apply a chain rule to that. So let's say it's 1 over ax with respect to x. Then we're going to have ln of this thing at the bottom, so ln of ax, but also we're going to divide that by the derivative of this part, of the bottom part. So derivative of ax, if we differentiate ax, you just get a. Okay, so that is how the chain rule works, right? We divide by the derivative of the inside. Okay, so when we also have a constant, we can take out the constant. So we can say that's just same as 8 times the derivative from, or the integral from 1 to 4 over, 1 to 4 of, we've taken out the 8, so what's left is 1 over 2x plus 1 with respect to x. Okay, great. So that gives us 8, and now let's do the integration. So we're going to say it's 1 over something, so it's going to be 1 over 2x plus 1. But then we also have to divide this, so divide this whole thing by the derivative of this. So if we differentiate 2x plus 1, we get 2. Okay, and then we have to plug in 1 and 4. Okay, let's simplify that a little bit. So 8 times, and then, so 1 over 2x plus 1 divided by 2 is going to be, well, we can probably just do it like, oops, like this actually. We can do 8 divided by 2 is going to be 4. So 4 times 1 over 2x plus 1 from 1 to 4. Okay, so what we want to do now is substitute the 4 in and then substitute the 1 in and subtract those from each other. Okay, so we're going to have 4 times 1 over 2 times, wait a minute, I forgot the ln part. I'm lying to you here. My apologies. So that's equal to 8. And then it's going to be ln of 2x plus 1. Sorry, not 1 over, I meant ln. And then divided by the derivative of this, which is 2. Again, that's from 1 to 4. Okay, so 8 divided by 2 is going to be 4. So it's 4 ln 2x plus 1. We're doing that from 1 to 4. So first we substitute in the 4. So it's going to be 4 ln, and then 2 times 4 plus 1, minus, and then it's going to be 4 ln 2 times 1 plus 1. Okay, so here let's simplify that. It's going to be 4 ln, and then 2 times 4 is 8 plus 1 is 9, so 4 ln 9 minus, and there's going to be 4 ln, and then 2 times 1 is 2 plus 1 is 3. Okay, this looks good so far. So now we want to combine the lns into a single thing. So a couple of ways we can do this. One way is to factorize. So let's take out the 4, and then we're left with ln 9 minus ln 3. That gives us 4, and then ln, if we do minus, so if we have ln of a minus ln b, we can say that's the same as ln of a divided by b, right? That's a rule of logarithms. Okay, so we're going to use that law and say that's then ln of 9 divided by 3, which is 3. Let me just maybe write that step in. So 9 divided by 3. So that gives us 4 ln 3. And then another law of logarithms is if we have log a to the power n like that, we can say that's the same as taking that thing to the front, making it n log a. And we can also do that in reverse, right? By taking this thing as an exponent. So that's exactly what we'll do here. We'll do ln 3 to the power 4. And what is 3 to the power 4? That's 81. Okay, let me just also show if we didn't do the factorizing part, so we did another thing. So we could first do this rule where we make that an exponent for both. So we could have then ln 9 to the power 4 minus ln 3 to the power 4. And then we could say, okay, that means ln of 9 to the power 4 divided by 3 to the power 4. Okay, and that gives us ln, and you can just type that in the calculator, or you can say, we know 9 is the same as 3 squared, so 3 to the power 2 to the power 4 over 3 to the power 4, which would give us ln, and then 3 to the power 8 over 3 to the power 4, and then we know if we have the same basis, then we can write that same base and subtract the exponent. So 8 minus 4 is 4, and that again gives us ln 81. Okay, a couple of ways we can do that. So big thing here is to know that if you've got 1 over something, if you integrate that, it becomes ln of that thing. And then we also have to remember with the chain rule to divide our answer by the derivative of the inside part. Okay, next up, question 3. Solve this inequality. Okay, so we've got 2 absolute value things. So my advice would be, if you've got 2 absolute value things, the easiest way to think about this is just square both sides, right? So we're just going to start this by saying that's going to be 3x plus 3 squared less than, and then x plus 5 squared. This is, I believe, the simplest way to do that. You've got two absolute value sign things. Okay, so then squared. Remember, squaring doesn't mean square and square. It means multiply the bracket by itself. And I'm going to skip writing that out. But that's going to give us then 9x squared plus 6x plus 6x, so that's 12x. Sorry, plus 9x, so that's 18x. And then plus 9, which is less than this one. If we square it, we get x squared plus 5x, so that's 10x. And then plus 5 times 5, which is 25. Okay, so let's collect all the like terms. So 9x squared minus x squared is going to be 8x squared. Then 18x minus 10x is going to be 8x. And then 9 minus 25 is going to be negative 16, less than 0. Let's divide everything by 8 just to make it a bit easier. So that's going to give us x squared plus x minus 2 is less than 0. And now again, this one can factorize, but if it couldn't, we could also just use our quadratic formula. So it's going to be x, and we have a plus 2 and a minus 1. Okay, so now most people would get this part right, but now the next part, a common mistake would be to do this. So let's say red, what we do not want to do. So do not from here say that means x plus 2 is less than 0 or x minus 1 is less than 0. That is not correct. Okay, so what we should do is we're going to say our critical values are, and the critical values are x plus 2 equals 0 or x minus 1 equals 0, which gives us x equals negative 2 or x equals 1. So those are our critical values. And now we use them to sketch a little graph. We see this is a parabola. It's a smiley face parabola here, right? Oh, let's do that. So the smiley face parabola, because the a value is positive, it's a 1, that's positive. It's a smiley face parabola, and these are our x-intercepts. So at negative 2 and at 1, something like that. Right? Doesn't have to be accurate. So at negative 2 and at 1. That's the most important part that we want to draw. And now the question is, where is this parabola less than 0? So where is this parabola below the x-axis? Okay, below the x-axis. So it's below the x-axis for this little part here, right? This part is the part below the x-axis. That's between negative 2 and 1. So between negative 2 and 1. And that is our answer. anything between -2 and 1. And if you've done this and you're unsure, you can always just take a value in between and test it to see does it work, and test the value outside of this to see if it doesn't satisfy it, to see if you were right. Okay, so again, two absolute value signs, square both sides and solve from there. And remember, with an inequality, then we do not just like an equation say the one is less than 0 and the other one is less than 0. That would be wrong. We find our critical values. So you have to write, we're doing some rough work, or we're writing our critical values, because we can't just change an inequality to an equal sign. So say we're finding our critical values, find them, and then draw a little sketch for yourself with your correct x-intercepts so that you can see where is the graph below this if it's less than. If it asked for greater than, it would be this part. Oh, let me do a different color for this. Greater than would be that part of the graph and that part of the graph, right? So that would be everything to the left of -2 and to the right of 1. So in that case, we would say x is less than -2 or x is greater than 1. So that would be the answer if this thing was greater than. But it's not, it's less than, so we look for below the graph. So that's that part, and that's between -1, 2, and 1. All right, let's get on to the next question. Okay, supermarket campaigns to reduce the use of plastic bags. Now the number of bags N used in a particular week is given by this formula. So number of bags equals 5,000 e to the power -0.02 t, where t is the number of weeks since the campaign began. Okay, let's sketch the graph. Okay, so we can see here this is an exponential function, right? That it has this form, y equals a times b to the power x or something times x plus q, where this is our horizontal asymptote. So in this case it's plus 0, right? So our horizontal asymptote is just going to be this line. Okay, I'm going to draw that in. What did I do here? This. Okay, so let's draw that in. So there's our horizontal asymptote. Let me actually just do that instead of with the arrow. Okay, so there's our asymptote. And we also need to find our y-intercept, or our n-intercept in this case, right? So our n-intercept, that's going to be where x equals 0, or in this case t equals 0, right? Where this thing equals 0. So let's find that. So it's going to be n equals 5,000 e to the power -0.02 times 0. Okay, so simplifying that gives us 5,000 e to the power, and -0.02 times 0 is 0. And then that gives us 5,000 times e to the power 0 is 1. So that just gives us 5,000. Right, so at 5,000, let's make it over there, 5,000. Okay, so there's 1 point on our y-intercept. We won't have an x-intercept because we have an asymptote there. Okay, so now what else to remember? We remember that if this value is bigger than 1, then our graph is increasing. But if this is negative, let me just do another color here. So if this is a negative x, then that's just, so let's actually do this. So b to the power -x is the same as 1 over b to the power x, right? So this -x actually changes this around. So instead of going up like this, it's going to be going down. So our graph is going to look like this. It's going to be a decreasing graph, something like that. Something like that. Okay, there's our graph. So it's exponential going down, 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 but it never touches the x-axis because that's our asymptote. Okay, success. We've drawn the graph. Now, calculate the number of full weeks before the bags used is halved. Okay, so we started with 5,000, so we want to find out when is it 2,000. I mean 2,500. So we're going to say 2,500 equals, and our equation is 5,000 e to the power -0.02 t. So we want to find out what t is. So let's first divide both sides by 5,000. So that's going to give us a half equals e to the power -0.02 t. All right. So now our unknown is an exponent, so that's usually when we want to use logs. And we want to use log with the base e because we have an e here. So we're going to use ln. So let's just take ln of both sides. So ln of a half equals ln e to the power negative 0.02t. So we'll have ln of a half equals, and now we're going to use that rule again, which says we can take our exponent to the front. So negative 0.02t times ln e. But what is ln e? Ln e is just 1, so we can just cancel that, because that times 1 is just itself, right? And that's why we use ln, because of this e. Okay, and now just divide both sides by negative 0.02t. So ln a half divided by negative 0.02 equals t. And that we can type on a calculator. So let's do ln of a half divided by, and then negative 0.02. So that gives us 34.6 something. So 34.6 something something something. Okay, so after 34 weeks, it's going to not be right, but after 35 weeks, then we will have definitely reduced it. Right, so it's going to take more than 34, but less than 35 weeks before the number of bags is halved, and they ask for full weeks. So after 34 full weeks, it won't be done yet, but after 35 full weeks, it will be done. So t equals 35. And we probably just want to say 35 weeks, because they asked for weeks, right? So we always want to include our right units that they asked for. All right, so that was question 4a and b. Then question 5. Okay, let's differentiate. So differentiate this. So we've got two functions multiplied together, so we're going to have our what do you call it, the product rule for differentiation. So the product rule, let's just do a recap of the product rule. So if we have some function, let's say f of x equals g of x times h of x. So we've got a product. Then if we want to differentiate the whole thing, our product rule says we keep the first one, we differentiate the second one, plus, then we keep the second one, and we differentiate the first one. Right, so you keep one of them, differentiate the other one, plus, and then you do the other way around. Keep the other one and differentiate the other one. Okay, so that's the idea here. So let's get into that. So we're going to say this function is basically, so we've got x times ln x minus x. Okay, so these two functions, that's going to be a product rule for this part. So if we want to differentiate that, we're going to say, okay, so let's say if we want to differentiate that, we're going to say that's equal to, okay, keep the first one, differentiate the second one. If we differentiate ln x, we get 1 over x. Plus, now we keep the second one and differentiate the first one. So differentiating x, we get 1. And then we've also got the minus x at the end, so if we differentiate minus x, we get minus 1. Okay, let's simplify this. So x times 1 over x, the x's will cancel, we've got 1. And then plus, ln x times 1 is ln x, and then minus 1. And then 1 minus 1 cancels out, so we just have ln x. All right. So this is equal to ln x if we differentiate that. Now, hence, evaluate this. And now we have to integrate ln x from 1 to 3. Okay, so if we differentiate something, integrate just works the other way around. So we know if we integrate ln x, we get that. So that's a nice help. So let's just write on the question. So we're integrating from 1 to 2 ln x with respect to x. Okay, so the integration part, that's this part, right? If we integrate ln x, we get that, because we know if we differentiate that, we get ln x. So integrating ln x, we get x ln x minus x, and we want to do that from 1 to 2. Okay, so we substitute in 2 first. So 2 ln 2 minus 2 minus, and then we're going to do 1 ln 1 minus 1. All right, so 2 ln 2 minus 2. So I'm going to do this where you can take that as an exponent. So that's going to be ln 2 squared, so I'm just going to write ln 4 minus 2, and then minus ln 1, and then minus 1 makes plus 1. Okay, so we've got ln 4 minus ln 1, and then minus 2 plus 1 is going to be minus 1. And again, we can write this as a single ln. Ln 4 minus ln 1 is going to be ln 4 divided by 1, so that's just ln 4 minus 1. And there we go, that's your answer. And if you wanted to see what that looks like in decimal, we can do that. So ln 4 minus 1. So 0.386 for this. Well, 0.3863. 0.3863. Well, 386 is fine for 3 significant figures, right? Okay. Question 6. Show that this equation can be written in this form. Okay. So let me just write the question again. So sin x plus 60 equals 2 times cos x plus 30. Okay, so what we want to do here, or my instincts at least, is we use our compound angle formulas to just expand this out. And we can see there's some nice values like sin 60 we know square root 3 over 2, so there's something that seems right there, and cos 30 is also a square root 3 over 2 thing, so that seems right to expand this. Okay, so sin x plus 60 is the same as saying sin x cos 60 plus cos x sin 60. Okay, so if you're unsure about where this comes from, just go check compound angle expansion for sin and cos. Okay, so that's the sin expansion equals 2 times, and now the cos expansion is going to be cos x cos 60. Opposite sign of the plus, so that's a minus, and then sin x, that's cos x cos 30. Cos 30, right? That's a 30. And then opposite signs, so it's minus, and then sin x sin 30. Alright, so that looks good. Now cos 60 we know is a half, so that's a half sin x. And then sin 60, we know that's square root 3 over 2. So that's square root 3 over 2 cos x equals. So cos 30, well, let's just keep the 2 outside first. Okay, 2, and then cos 30 is square root 3 over 2 times cos x. And then minus sin 30 is a half, so half sin x. Okay, then we can multiply this 2 in. So if we multiply this 2 in, it's just going to cancel out with that, right? It's just going to cancel out those 2's. Okay, so now let's get all the cos's on one side, sins on the other side. So I'm going to keep the, let's say, the sin on the left-hand side. So we've got half sin x. And if we bring this minus sin x across, so it becomes plus sin x. Equals, and then on this side we had square root 3 cos x. And then we're going to bring this one across, so it becomes minus square root 3 over 2 cos x. Okay, so half sin x plus sin x is going to be 3 over 2 sin x. And then square root 3 minus square root 3 over 2. So let's just show how we get to our answer. So we're going to say, put that over 2, so we have to multiply by 2, minus square root 3 over 2. So that's going to be 2 root 3 minus root 3 is just going to be root 3 over 2. Okay, so this part is just going to be square root 3 over 2 cos x. And then we can multiply both sides by 2, so we get 3 sin x equals square root 3 cos x. And then let's divide both sides by cos x. So 3 sin x, let me do this actually. I'm just going to show dividing by cos x. Because now sin x over cos x is tan x. So we've got 3 tan x. Oh, that's not what we want to do. Sorry, we don't want to do a tan thing. We have our answer here at top. So this already looks pretty close. So we want cos x by itself. So all we need to do is divide by square root 3, right? Divide by square root 3. So 3 divided by square root 3 is square root 3. So square root 3 is sin x equals, and then the square root 3's cancel out there, and that's cos x. Okay, so there we go. We've written it in that form. Hence means we have to use our previous answer. Find the acute angle for which this is true. So we know this whole thing can be rewritten as this. So all we need to do is solve this equation. So we just need to solve this equation. Square root 3 sine x equals cos x. Okay, let's divide both sides by cos x. So sin over cos would be tan. So square root 3 tan x equals, and cos divided by cos is 1. So let's divide both sides by square root 3, and we get that. So now to find x, we can say our reference angle equals arctan, or shift tan in calculator language, of 1 over 3, or 1 over square root 3. Okay, so that is going to give us, that's 30 degrees, right? And we're working in, okay, so we're not told if, it's degrees, here we see, it's degrees, yeah. We're working in degrees. And just to show, so if we do arctan of 1 over the square root of 3, we get 30 degrees. Okay, so that's 30 degrees, and we also should know that from our special triangles. So that's 30. Now we saw here tan was positive, this is a positive value. So in the quadrants, tan is positive in these two quadrants, right? So in the acute angle quadrant and that one. So in the acute angle is fine, so this is an acute angle. So that's fine, so it's, our answer is 30. So x equals 30 degrees. Alright, if they asked for like a reflex angle, let's say they said here reflex angle, then what do? Reflex is over here, right? It's these two quadrants between 180 and 360. That's a reflex angle. So then we would have to say, okay, where is tan positive again? That's in this one, so we'd have to go 180 plus our reference angle, and that would be 210. So that's also where this would be true if x is 210 if it's a reflex angle. Okay, let me just get rid of that. We don't really want to show this reflex angle things on here. Okay, next page. How many pages do we have? So this is page 9 and 10. We only go to 15. Okay, so we're already making some progress. Okay, what color did we use previously? Okay, so let's move on to green again, I think. Question 7. The parametric equations of a curve are this. Okay, so x and y are both dependent on t, and the curve meets the x-axis at 2 points. Okay, so the x-axis is where y is 0, right? So if we have our thing here, the x-axis here, this is where y is 0. Okay, so that's useful to know. So we can let's already do that. Let's find the x-intercepts. So our x-intercepts, so that's when y equals 0. Okay, so let's make y 0. And that's the equation where that contains y. So we'll say 0 equals t times 1 plus t. Okay, so that means either that's 0 or that's 0. So if 1 plus t equals 0, that means t equals negative 1. So these are two t values for the x-intercept. Okay, so we can also find the y values when t is 0 to get our coordinates of the, well, the y values will also be 0, right, if we substitute that in here, because we know y is 0 at that point. So we can also find the x values for this. So to find the x values, we can say x equals 2 times 0 squared minus 18 times 0. Okay, so that's going to give us x equals 0 minus 0 is 0. Or we're going to say x equals x equals 2 times negative 1 squared minus 18 times negative 1. And that's going to give us x equals, okay, negative 1 squared is 1, 1 times 2 is 2, negative 18 times 1 is positive 18, so x equals 20. Okay, so our coordinates for the x-intercepts are 0 and 0, or 20 and 0. Okay, so those are our x-intercepts. Okay, now find the equation of the tangent to the curve at each of these points. Okay, so a tangent has the equation. I don't want to do black. Let's do this. So a tangent line. Whoa, let's rewrite that. A tangent line What equation does a tangent have? It's a line, right? So it's y equals mx plus c. So we need to find the m and the c values for this time. The m is the gradient. So the m here is going to be the same as the gradient of the curve at the points, at both of these points. Okay, so let's first find the equation for the gradient of the curve. So we want dy dx, right? That's the gradient. So dy dx, that's going to be our gradient. Okay, and how do we find dy dx? Well, we can say dy dx is the same as saying dx or dy dt times, I'm going to use a dot for times, otherwise it looks like an x, times dt dx. Right, because then the dt's will cancel out and we will have dy over dx. Okay, so dy dt, so just differentiate y with respect to t. So let's first rewrite this as t plus t squared, right, if we multiply the t in. So that's what y equals. So if we differentiate that, so that's going to be, if we differentiate that, differentiating t is 1, differentiating t squared is 2t. So that's going to be dy dx, or dy dt is going to be 1 plus 2t. Okay, and then for this one, if we have x equals 2t squared minus 18t, and we differentiate that, differentiating that gives us 4t minus 18. Okay, so that's dx dt. And what is dt dx? That's just the other way around, right? So just swap the fraction around, because this is over 1, so now dt dx is going to be 1 over 4t minus 18. Minus 18. Okay, so that is our gradient. And now we can probably just simplify that a little bit. Let's just so multiply at the top. So we've got 1 plus 2t over, and then at the bottom we've got 4t minus 18. Okay, so that's dy dx. That's our gradient. So now to find our gradient, let's just write dy dx here. Now we want to find our gradient at these points. Okay, so at these points, that's when t equals 0 or when t equals -1. So for, let's just do colors here. So for this point, the m is going to be when t equals 0. Okay, so dy dx, or m, same thing, it's going to be 1 plus 2 times 0 over 4 times 0 minus 18. So that's going to give us 1 plus 0 is just 1, and then 4 times 0 is 0, minus 18, so negative 18. So that is our gradient when at this point for the curve. And then let's do this color. So at this point, that's going to be when t equals -1. So that's t equals -1. So our gradient there is going to be when t equals -1. So 1 plus 2 times -1 over 4 times -1 minus 18. So that gives us, so 2 times -1 is -2 plus 1, so that's -1 over, we've got -4 minus 18 is -22. The two negatives just cancel out and we've got m equals 1 over 22. Okay, so that's our two gradients at those 2 points. Okay, so far we've got y equals -1 over 18x plus c. And to find the c value, we can substitute this point in. And we can see the c is going to be 0, but just to prove, we substitute it in. So 0 equals -1 over 18 plus times 0. So times 0 plus c. So 0 equals 0 plus c, 0 equals c, right? So that gives us y equals -1 over 18x plus 0. So there is our one equation. And then at the other point, we also have the gradient so far. So far we know it's y equals 1 over 22x plus c. And to find c, we substitute in this point. So y is 0 when x is 20 plus c. So then 0, so this gives us 10 over 11. So if we take it across, it becomes -10 over 11 equals c. So our final equation, y equals 1 over 22x minus 10 over 11. Okay. And there we go. Those are our two equations. This blue part and this pink part. Okay, so there's quite a lot going on here. I can't see the marks here, but I'm assuming it's quite a number of marks for this. So what we want to do, the important thing is we want to find our gradient for this parametric curve. So this is the one important part. Let's do this. The one important part is this is how we find our gradient. dy dx equals dy dt times dt dx. So you have to differentiate both of them separately and then plug it in here to get your dy dx. So that's your gradient. We also know the curve meets the x-axis at 2 points, so we find those 2 points. How do we find those points? By making y 0. So we make y 0, then we get the 2 t values, right? We get the 2 t values. We plug those t values into the x equation to find the x values. And that gives us our 2 points then for the x-intercepts. Now we need the equation of the tangent at these points. So at these points, the gradient of the tangent and the gradient of the curve will be the same, which is why we said m equals that at those points. So at this point, that's when t was 0, so we substitute 0 into our gradient to find our gradient. We did the same for the other point. At this point, t was -1, as we can see there, so substitute t equals -1 to find the gradient for that curve, or for that line. Then, so we have here our gradient there. So that's the equation. We plug in this point to find our c value, and then we've got our final answer here. Same here, y equals our gradient mx plus c. Plug in this point here to find that c equals -10/11, and that gives us our final equation there. All right, quite a bit going on there, but hopefully you can follow what I was doing there. Next up, we've got question 10. Question 10. Let's start off with pink again here. Show that this equation has a solution between 2 and 3. Okay, let me draw this in a curve quickly. So let's say we've got something like that, right? And let's say this point here is 2 and this point here is at 3. Okay, so also I'm gonna have to draw it a little bit not as straight up. So let's say this curve goes like that. Okay, so when x is 2, then what is y? Then y is over here, and when x is 3, y is over here, right? So we can see here the y value here is negative, the y value here is positive. So that means the graph had to go from below the x-axis to above the x-axis between the 2 points. That's why we can say it has a solution there, because it crosses the x-axis between those 2 points, because one is positive, one is negative. And it would be exactly the same if we had some other curve. Let's say we have this curve, right? So between, let's say, 1 and 5, so at 1 the y value was positive, and at 5 the y value was negative. So definitely this equation, this line here, has a solution between 1 and 5, because at 1 it's positive, at 5 it's negative, so it must go through the x-axis between them. That's the idea here. Pretty straightforward idea. So we're just going to say, okay, what happens if it's at 2 and 3, if we plug those in and one is positive, one is negative, then we've shown it has a solution. Okay, so let's do that. So let's plug in 2. So 2 cubed minus 4 times 2 minus 2 is equal to, so that's 8, minus 8 is 0, minus 2 is -2. Okay, so there we have a negative value. Then we plug in 3. So 3 cubed minus 4 times 3 minus 2. That gives us 27 minus 12, which is 15. 15 minus 2 is 13. So that's a positive value. So one is negative, one is positive, so it has to cross the x-axis between these two points, between 2 and 3 somewhere. Okay, so that's enough to show that. Now show that this equation can be rearranged to form that. Okay, so x cubed minus 4x minus 2 equals 0. Okay, so we want to get an x by itself. We've got a root thing. Okay, so let's start by taking over the 2 to become positive 2. and then the negative 4x to become positive 4x. Now let's divide both sides by x, so that gives us x squared equals 2 over x plus 4, and then let's just take the square root. So square root of 2 over x plus 4. Okay, not too bad either, right? Feels pretty good after a long question like this one here on the right. Now, starting with x1 equals 2, use the iteration formula that we just found to find x2 and x3 correct to 5 decimal places. Okay, so we're going to start with x1 equals 2. And then, so we're going to find if x1 is 2, then x2 is going to be the square root of, and then 2 over the previous x, so 2 over x1. x1 was 2 plus 4. Okay, so what does that give us? So 2 over 2 is 1, square root of 5. So that gives us the square root of 5. And we need 5 decimal places. So we're doing square root of 5. Whoops, 5. So that's going to give us 2.23607. 23607 if we round off. 2.23607. Okay, then x3 is going to equal to square root of 2 over, and our previous x was this one, was the 2.23607 plus 4. So that's going to be, okay, let's type that on the calculator again. So this time I'm going to type the whole square root of, and then we've got 2 divided by 2.23607 plus 4. Okay, so that gives us 2.21234. Okay. Now find the solution of this equation correct to 4 decimal places. Okay, so we have to keep going with this formula until the first 4 decimal places rounds off to the same first 4 decimal places. Okay, so let's go to x4, will be the next one. So x4, we're going to have 2 over, 2 over this whole thing here, so that 2.21234 plus 4. Okay, so this one, and now we're just going to replace this with a 2.1234, and that gives us this. Okay, 2.21450. 2.21450. Then x5 equals square root, and we do the same thing, but now we use the 2.21450 plus 4 and see what we get. So until the first 4 decimal places round off to the same thing. Okay, so we're going to do that, but now again we're going to change this to 2.21450. That gives us 2.21430. 2.2130. Wait, what? 2.21430. 2.21430. Okay, so the first 3 decimal places are already the same, but we need the first 4 to be the same. Okay, so we keep going. x6 equals, again, square root 2 over 2.21430 plus 4 equals. Okay, so now we're going to change this to that. So 2.21432. 2.21432. Okay, so now these 4 are the same. So there we go. 2.2143. 2.2143. So that is now the same. So once you get to 4 decimal places that are the same when rounded off, that is your answer. Okay, question 9. Question 9. Fine, so we have to integrate this. Okay, let me just rewrite the question. Integrating 4 minus 2e to the power 3x over e to the power 3x. Alright. So how do we want to write this? We can split it up into two different fractions. That might be the nicest way to do that. Okay, I'm going to do that. So I'm going to split it up and say that's the same as the integral of 4 over e to the 3x minus 2e to the 3x over e to the 3x. And then we can simplify that even further by saying that's then 4e to the negative 3x minus, and then the e to the 3x is cancelled out here, so minus 2. So we're going to do that whole thing with respect to x. Alright. So we can integrate this first. So integrating e, we just rewrite the whole thing. And then we divide by the derivative of the exponent. So divide by negative 3. Alright. And then this one, we're just adding an x. Okay. So that's that. And then we just say plus c. Okay. So if you don't have any specific values here that you want to integrate from like 1 to 2 or something, just remember to add your plus c at the end. This looks fine. I don't see that we can, there's no obvious simplification to do here, so that's probably fine. Okay, now by expressing 4 cos squared x in terms of cos 2x, integrate 4 cos squared x. Okay. Okay, so this actually, this is a little bit tricky, although it's not a long thing to do, but it's a little bit tricky, I think, to think about how can we rewrite this as this. Okay, so I'm going to do this. I'm going to say 4 cos squared x. So first thing is, I know that cos 2x. One way to rewrite cos 2x is 2 cos squared x minus 1, right? So this is what informs my decisions of how to proceed here. We know that. So I'm going to start with the 4 cos squared x and just say 4 cos squared is the same as 2 times 2 cos squared x. Okay, so the 2 cos squared x, it looks sort of right here, but we need to add a minus 1. So we're going to say 2 cos squared x minus 1. But now we've actually added minus 2, so we need to add positive 2 again. Alright, so now this is the same. So now this whole thing is the same as 4 cos squared x. Okay, good. So now we have rewritten it in almost. So 2 cos squared x minus 1 is the same as cos 2x, right, plus 2. Okay, so now we have rewritten this, or this, in the form of that. Okay, so this whole thing is the same as 4 cos squared x. We didn't change anything, we just rewrote it in a different form. Okay, so now we can integrate this. So we want to integrate 2 cos 2x plus 2. Okay, so that's, again, we can factor out the 2 if we like, and I probably would do that, but it doesn't really matter. So yeah, I would probably do that. I would take out 2 as a common factor, so that would be taking out 2 as a common factor. Then we'd have cos 2x plus 1. Remember to write with respect to x. So then the 2 can go out to the front. We have 2 times the integral of cos 2x plus 1. But this is not necessary. That I just prefer doing that. I like factorizing when I can. It usually simplifies matters. Okay, so that's then equal to 2, and then we integrate. So cos 2x, if we integrate that, becomes sine 2x. But then we need to remember to also divide by the derivative of the inside part. So derivative of 2x is 2. Plus, okay, and then if we integrate 1, we get 1x. Alright, so if we multiply this 2 in, the 2 and 2 cancel out, so we've got sine 2x plus, and then 2 times x is 2x. So sine 2x plus 2x, and then plus c. Remember to add your plus c. Alright, next up. So we've got an equation of a curve. Show that dy dx equals this. Okay, so here we have implicit differentiation because it's very difficult to rewrite this in the terms of y equals or x equals. If you want, you can try to rewrite this as y equals. Let's actually check if we can. We probably can. So yeah, let's first do that. So I'm guessing they want us to do implicit differentiation because of that. But let's see what happens if we just try to get y by itself first. So then we get 3xy minus 5y equals 2x squared plus 6. Then we can factor out a y, and we have the 3x minus 5 equals 2x squared plus 6. And then we can say y equals 2x squared plus 6 divided by 3x minus 5. Okay, yeah, we can definitely do that. And then we can differentiate this with the quotient rule. But that's going to be quite messy. So implicit differentiation actually works nicer here. Let me just see what happens if we try. Oh, the only problem is now you don't have y's in your answer. Okay, yeah, so we do want y's in our answer, so we do want to do implicit differentiation to show that it's that. We could have done the other way and then substituted back, but that's definitely going to be messy. Okay, so for implicit differentiation, we're going to differentiate both x and y with respect to x. Okay, so I'm just going to start doing this and I'll explain as we go along in case you're unfamiliar with it. So let me just first rewrite the equation. So 3xy minus 5y minus 2x squared equals 6. Okay, so we want to differentiate each of these terms with respect to x. So since it's implied that y is a function of x, that's where the idea of implicit differentiation comes from. So this will then be a quotient rule because we've got one function and another function, right? A 3x and a y. So with respect to x, we're going to say it's keep the first one, differentiate the second one. Now differentiating y, so if we differentiate y with respect to y, it's going to be 1, but then we have to put times dy dx. So every time there's a y, you differentiate the y thing, but also times dy dx. Okay, so that was first, differentiate second, plus keep the second one, differentiate the first one. So if we differentiate 3x with respect to x, we get 3. Okay, so that part is now done. Now we've got this part to go. So negative 5y, if we differentiate this with respect to y, we get negative 5 and then dy dx. Negative 5 and then times dy dx. So every time we're differentiating y, we add the dy dx at the end. And now this one, if we differentiate that, we get 2 times negative 2 is negative 4, x to the power 2 times 2 minus 1 is just 1. And if we differentiate 6, we get 0. Alright, now we want to collect all the dy dx's on one side. So 3x dy dx, and then minus 5 dy dx equals, so we're going to take over the minus 4x to become positive 4x, and the positive 3y to become minus 3y. Then we factor out a dy dx. So what's left is 3x minus 5 equals 4x minus 3y, and then we just divide by the bracket. So dy dx is then equal to 4x minus 3y over 3x minus 5. Alright, and that's exactly what they wanted there. Okay, if any of you tried getting y by itself first, differentiating that and then substituting some values back to get like this, please let me know in the comments and we can have a look at that together. Okay, now find the equation of the normal to the curve at the point where x equals 1. What does the normal mean? That's the opposite of a tangent in some sense, right? So let's say we have a curve. Then if we add a tangent to the curve, it would be like something like that. Now the normal would be something that's perpendicular to the tangent. Perpendicular to the tangent, right? So that would be the normal to the curve at this point. Let's say that was x equals negative 1, and this line would be the normal to the curve. It is perpendicular to what the tangent would be at that point. Okay, so we need to find the gradient. What do we know about perpendicular lines as gradients? If lines are perpendicular, then the two gradients, the gradient of the one line times the gradient of the other line, that are perpendicular to each other equals -1. So that's important in this case. So let's find the gradient of the tangent at this point. So here's our gradient. So first let's find a point. So if x is -1, what's y going to be? So let's plug in x equals -1 there. So 3 times -1 times y minus 5y minus 2 times -1 squared equals 6. Okay, so that gives us -3y minus 5y equals 6. And then this is 1 times -2 is -2. Take it over, it becomes +2. So -8y equals 8. So y is also equal to -1 at that point. Okay, so we've got a point where for x and y, coordinate, let's do this, -1, -1. So that's a coordinate that we have now. So at that point, what is our gradient? Well, we just plug it in. So our gradient is the y dx. So, and we want to do it when we substitute this point, -1, -1, right? So it's going to give us 4 times -1 minus 3 times -1 over 3 times -1 minus 5. Okay, so it gives us -4 plus 3 is -1. And then -3 minus 5 is -8. So that's just 1 over 8. Okay, so that's the gradient of the tangent at this point. So what would the gradient of the normal be? Remember, we're looking at this. So we know that 1 over 8 times the gradient we're looking for must be equal to -1. Okay, so we can just multiply both sides by 8, so we get m equals -8, right? We divide by 1 over 8 here, just to prove that. Let's just say -1 divided by 1 over 8. 1 over 8, oops, gives us -8, right? Okay, so far we know we've got y equals -8x plus c, and here we've got a point that we can substitute. So y is -1 when x is -1. So -1 equals -8 times -1 is +8. So minus the 8, so -9 equals c. And then our final answer is y equals -8x minus 9. So there is the equation of the normal to the curve at that point. Page 13, 14, and then 15, then we're done. Last 3 pages. So this page, and then the next one. Question 11. Okay, show that this equation can be expressed as this. Okay, so let's just rewrite the equation first. So ln 3 plus 2 ln x minus ln 2x minus 1 equals 2 ln 2. 2 ln 2. Okay, so we've got a lot of lns going on here. So what we can do is we can simplify this to a single ln on both sides, because if we can get to a position like this, ln of something equals ln of something else, then we can say that means that this thing equals that thing. So then we can sort of not really cancel them out, but in some sense you can think about it cancelling out the lns, even though that's not really what's happening. Okay, so to do that, we first want to get rid of all the coefficients. So that's going to be ln 3 plus, now we're going to use that where that becomes an exponent again. So that's going to be ln x squared minus ln 2x minus 1 equals 2 ln 2. So that's going to be ln 2 to the power 2. So that's 2 to the power 2 is 4. Okay, so now we can combine all the lns here. So ln, and then everything that has positive in front goes to the top. So 3 x squared, and then with the minus in front, that goes to the bottom. So 2x minus 1 equals ln 4. Okay, so now we can, like we said, sort of ignore or cancel the lns. Okay, so this implies that 3x squared over 2x minus 1 is equal to 4. Okay, let's multiply both sides by 2x minus 1. So that gives us 3x squared equals 4 times 2x minus 1. 3x squared equals 8x minus 4. Let's bring everything across. So 3x squared minus 8x plus 4 equals 0. And that is exactly what they wanted us to show. Success. Hence, solve this equation. Okay, so now we can see this looks very similar to this. So what's the difference? What's the difference? Okay, so ln 3 is the same. 2 ln, we had 2 ln x, here we have 2 ln 2 to the power n. So it looks so far as if x is just equal to 2 to the power n, because that is just replaced with that. Let's just make sure that holds true. So we've got ln 2x, so that. So is 2x equal to that? So if x is this, then what is 2x? So if we multiply both sides by 2, then we get this. And what happens if we multiply with the bases are the same? Then we add the exponents, right? So that gives us 2 to the power n plus 1. N plus 1. And that's exactly what we see here, yes. So definitely x equals 2 to the power n. Okay, so x equals 2 to the power n. That we know. So then we can just say, but we know we can rewrite this then in that form. Okay, so all we need to do is solve for x in this equation, and then we can solve for, then we can say that's the same as 2 to the power n. Okay, so 3x squared minus 8x plus 4 equals 0. So how can we solve that? Well, we can factorize or use our quadratic formula. Let's factorize this one. So 3x and x, and we've got minus 2 and minus 2. Okay, so that gives us x equals 2 over 3, or x equals 2. But we know x is actually 2 to the power n. So that means 2 to the power n equals 2 over 3, or 2 to the power n equals 2. So this one is pretty nice. Bases are the same, so therefore exponents are equal. So there we go. Or, but now this one here, again have an unknown, but the bases are not the same, so let's use logs. So log 2 to the power n equals log of 2 over 3. And we do this because now that can move to the front. So we've got n times log 2 equals log of 2 over 3. And then we just divide both sides by log 2. So we've got log of 2/3 divided by log 2. And then we can just solve that. So log of 2/3 divided by log of 2. And that gives us negative 0.585. Negative 0.585. Okay, so these are our two answers. Now, since we were working with logs, we just have to check that both of them are valid. Okay, so if we substitute n equals 1, that'll give us, so ln 2, because basically we can't have ln of a negative number, right? So this has to be positive, and this part has to be positive. Okay, so let me do that in a different color actually. Okay, so 2 to the n must be bigger than 0, than 0. And also 2 to the n plus 1 minus 1 must also be bigger than 0, because we can't have ln of a negative number. Okay, so here let's just substitute in 1. So 2 to the power 1, is that bigger than 1? Yes, that works. So that one works so far. And on this side, what's bigger than 0? I was lying here. It's not n equals, yeah, it is n equals 1. Okay, so it's my pen here. Okay, so is 2 to the power 1 bigger than 0? Yes. Okay, so that works. Is 2 to the power 1 plus 1 minus 1 bigger than 0? So 2 to the power 2 minus 1. So that gives us 3. 3 is bigger than 0, yes. Okay, so this one works everywhere. Now we also have to check the other one. Okay, so 2 to the power negative 0.585. 2 to the power negative 0.585. Let's check that. That's definitely, it's going to be positive. But let's just show that on the calculator. 2 to the power negative 0.585. Oops. 585. That's 0.66 something. So 0.66 something. That is bigger than 0, yes. And over here, 2 to the power n, so negative 0.585 plus 1 minus 1. So 2 to the power of that plus 1 and minus 1. That's 0.33, that's also fine. Right, 0.33, that's also bigger than 0, so that also works. So both of those answers are fine. Remember, with logs, we always have to test our answers to see that it works. And if you're unsure about when it should be bigger than 0, just plug it into this whole equation and see if you get an error or not. Okay, question 12. So express 3 cos theta plus 3 sine theta in the form r cos theta minus alpha, where r is positive. Okay, so this, if you want to look up how to do this, you can look up R formula, or you can just look up something very similar to this. You can even type this equation in Google. It should give you lots of nice pages in how to do this. Basically, our R is, okay, let me do this. Let me say this has the form A cos theta plus B sine theta, right? So if we have this, and we want to write this in the form of r cos theta minus alpha, then we're going to say r is equal to the square root of a squared plus b squared. Okay, so that's the a and that's the b. So again, we see a and b there. And so that's how we find the r. And then to find the alpha, we're going to say tan of alpha is equal to b over a. So that's going to be this over this. Okay, so that's our b over a. Okay, so there is our basic rules. Now, so let's solve that. Let's apply that. So in our case, we've got, oops, 3 cos theta plus 3 sine theta. Okay, so in our case, r is going to be the square root of 3 squared. So a squared plus b squared. 3 squared plus 3 squared. So that's going to simplify to square root 18, which I believe simplifies to 3 square root 2. So there's our r. And we're going to say tan alpha is equal to b divided by a. So b over a. And then to find alpha, we're going to say that's arctan of that number, 3 over 3. And we see here we're working in radians, so we have to find a radian answer. So alpha equals arctan of 1 is going to be pi over 4 in radians. Let me just check. I'm not sure if this, see here we can choose radians, but I don't actually know how to do this here. The arctan of 1, it just gives the degrees. 45, it's 45 degrees. So sorry, I can't show that on the calculator now, but that's basically the idea here. All right, so yeah, that's, just make sure that's, and alpha is between 0 and half pi. Pi over 4 is, a quarter pi is between 0 and a half pi, and that's fine. Okay, so so we need to, our final answer, so we found alpha and r, so we just need to rewrite it. So we're going to say that's r cos theta minus alpha. Okay, so there is our final answer. Hence, okay, so again we can use our previous result. Find the smallest positive value of theta which satisfies this equation. Okay, so we know this whole equation can be rewritten as 3 root 2 cos theta minus pi over 4. Okay, so now we need to find what is the smallest value of theta that satisfies this, and equals square root 2, equals square root 2. So this whole thing can be rewritten as this part, and then equals square root 2. Okay, so now we need to solve for theta. So let's first divide both sides by 3 root 2, so we get cos of theta minus pi over 4 equals, So square root 2 divided by 3 square root 2 is going to be 1 over 3. Okay, now we can say our reference angle equals arc cos or shift cos of 1 over 3. So that's going to give us, and we're working in radians still. Ugh. Yeah, working in radians. So now how do I get this into radians? Radians. No, I don't know how to do. What if? Oh, okay. Wait. Degrees to radians. Yeah. Okay, there it goes. Okay, 0.79 radians. Okay, now I see. So we're gonna do arc cos of 1 over 3. Okay, so that's 1.23 radians. Okay, so that's 1.23 radians. Okay, then so we want to do our angle actually now. So our angle is theta minus pi over 4 equals, okay, our reference angle. So let's just first check which quadrants are we working in. Okay, so we had cos was a positive value. So where's cos positive? Here and here, right? So it's in the first quadrant and in the fourth quadrant. So in our first quadrant, we just have our angle equal to 1.23 plus k times 2 pi, where k is an integer. That's our general solution, right? So that means we've got this value, and every 2 pi degrees, 2 pi radians is going to repeat. That's the same because 2 pi is the period, right? So if it was degrees, we would have said whatever the degrees answer was, 70.5 plus k times 360, where k is an integer. Okay, so let's get theta by itself. So theta equals, now I've got 1.23 plus pi over 4, or plus k times 2 pi, where k is an integer. Okay, so that gives us theta equals, so let's do 1.23 plus pi over 4. Okay, so 1.23 plus, and then pi over 4, so 2.015 plus k times, oops, sorry, that doesn't look like a k. K times 2 pi, where k is an integer. Okay, so that's the general solution for quadrant 1. And for quadrant 4, we're going to have our angle minus pi over 4 equals, so quadrant 4 is going to be 2 pi minus over here, right? So quadrant 4 is going to be 2 pi minus our reference angle. And our reference angle was 1.23. Plus k times 2 pi, where k is an integer. Okay, so let's get theta by itself. So theta equals, so I'm just going to say 2 pi minus 1.23 plus pi over 4. I'm just going to do that whole thing in one. So we're going to have 2 pi, oops, that's not 2 pi minus 1.23 plus pi over 4. Pi over 4. So that's 5.839. So 5.839, okay, plus k times 2 pi, where k is an integer. Okay, so that's the fourth quadrant solution. But what do we want? We want the smallest positive value of theta. Okay, so that's just going to be this 2.015. 2.015. Right, that's the smallest possible value of theta. Because if we subtract, so if we make k negative 1 here, and we subtract 2 pi from this, let's just show 2.015. If we subtract 2 pi from that, it's no longer positive, right? And if we add 2 pi to that, that's way too big, it's bigger. So this is the smallest value. Other thing we can check is the fourth quadrant, so the 5.839. 5.839. If we subtract 2 pi from that, it's negative, so it doesn't work. And if we add 2 pi, obviously it's going to be bigger, so obviously that's not going to work either. So that is our smallest value, it's 2.015. All right. Final question. Okay. Okay, so for this one, there will be at least two ways to do this. I'm probably going to do the longer one first, because the short one would be to use the tan double angle formula. So let's just write that down here. So tan 2x is equal to 2 tan x over 1 minus tan squared x, I think. 1 minus or 1 plus? I think it's 1 minus tan squared x. Okay, so that's the reason why I'm going to use the longer formula, because I'm not really sure about this one. We'll do it in two ways. We'll do first changing everything into sin and cos, because that always does work, even though it's sometimes a bit longer. But that's how I used to do it. Just change everything into sin and cos and work from there. Okay, so let's do that first. Then we can use this and see that it gets to the same answer. So first thing, change everything into sin and cos. So we've got 4 over, no, tan is the same as sin over cos. So sin 2x over cos 2x plus 5 equals tan x. And tan x is sin x over cos x. Okay, so 4 over 1 divided by sin over cos, so that's just going to become 4 cos 2x over sin x, sin 2x, plus 5 equals sin x over cos x. Okay, now the sin 2x we can change into 2 sin x cos x, right? But let's first multiply by sin 2x. It doesn't really matter what we do first, but I'm just going to show that first. So multiply everything by sin 2x, so then we get 5 sin 2x equals sin x times sin 2x over cos x. Okay, now I'm going to change the sin 2x into 2 sin x cos x, right? We know that one. So sin 2x is equal to 2 sin x cos x. That's the double angle formula that we know. Okay, so when we keep the 4 cos 2x plus 5 times 2 sin x cos x equals, and then at the top we've got sin x, and then we've got 2 sin x cos x over cos x. Okay, so the nice thing here is now that this cancels out. The cos x and the cos x cancels out. Okay, so here on the left we've got 4 cos 2x, and you'll see the cos 2x, I usually change this as late as possible, the cos 2x, because we've got 3 different options to change it into, and it's difficult to know which one will actually be useful. So I usually keep this one till last, the cos 2x, if I can. Then 5 times 2 is 10, so 10 sin x cos x equals, now sin x times 2 sin x is 2 sin squared x. Okay, so I'm just going to take this across and make it a minus, so just to save a bit of time, minus 2 sin squared x equals 0. Okay, so now we want to change the cos 2x into something. So I'm going to actually, let me think here. Yeah, let's change. Okay, now yeah, see, this is not difficult. I'm going to change this into cos squared minus sin squared. Okay, so 4, and then cos squared x minus sin squared x. Okay, so just to write down the rule here again, cos 2x, we've got different options. It's either cos squared x minus sin squared x, or it's 2 cos squared x minus 1, or it's 1 minus 2 sin squared x. So because of those 3 options, it's difficult to know which one is best. Now I'm going to use this one. I believe that's going to work out the nicest here. Okay, so plus 10 sin x cos x minus 2 sin squared x. Sin squared x equals 0. Okay, multiply the 4 in. So 4 cos squared x minus 4 sin squared x plus 10 sine x cos x minus 2 sine squared x equals 0. Okay, collect like terms. So 4 cos squared x, 4 cos squared x, and then plus 10 sine x cos x. So plus 10 sine x cos x. Oops, not cos y, cos x. And then we've got negative 4 sine x negative 2 sine squared x minus 4 sine squared x gives us minus 6 sine squared x. So minus 6 sine squared x equals 0. Okay, let's divide everything by 2 to make it a bit easier. So that gives us 2 cos squared x plus 5 sine x cos x minus 3 sine squared x. Okay, let's factorize this. There's going to be 2 brackets equals 0. There's going to be, one of them has to be 2 cos x, and the other one has to be cos x. And now we need to see how do we get 5. So 2 times 3 will be 6. And factors of 6, it's either going to be a negative 1 and a plus 6 to get this, or plus 2 plus 3. So we do need a negative. So that's going to be, let's do positive 3 sine x. Yeah, that's going to work. And minus 1 sine x. Okay, and you can verify that if you multiply this out, you get to the right answer. So here we can say this means that that's 0. So 2 cos x equals sine x, right? If we just take the sine minus sine x over, it becomes plus sine x. And then let's divide both sides by cos x. So we divide by cos x, we get 2 equals tan x. Okay, so that's one part answer so far. And on this side again, so let's also take the cos 3 sine x over, it becomes negative 3 sine x. Now let's divide by cos x on both sides. So 1 equals negative 3 tan x. And then let's divide by negative 3. So negative 1 over 3 equals tan x. Okay. So there we have our 2 values for tan x. And now we can find our solutions by saying, let's see, it's between 0 and 180, right? So yeah, so we can actually just solve both without the general solution idea, but you actually want to say the reference angle equals then arctan of 2. So our reference angle then equals, and we're working in degrees. Okay, so arctan of 2, 63.4. Remember, in degrees is 1 decimal place. Okay, so 63.4 degrees. And we're working, so tan was here positive, right? That's a positive value. So we're working in which quadrants? So tan is positive in the 180 plus quadrant and the normal quadrant, in these two. Tan is positive in these two, right? Okay, so we've got quadrant 1. It's just normal 63 degrees. And the other quadrant here, it's too big, right? It's bigger than 180. So 63 degrees, 63.4 degrees, that's one of our answers so far. Then over here, again, we find our reference angle. So that's going to be arctan of 1 over 3. So we're doing arctan of 1 over 3. So that's 18.4 degrees. 18.4. But tan here was negative, so tan is negative in this quadrant and this quadrant. But we're only interested in this one because from 0 to 180, just that part. So in this quadrant, it's 180 minus. So in quadrant number 2, we've got our angle is equal to 180 minus 18.4. So that gives us, so what is 180 minus that? 161.6. Okay, so 161.6 degrees. And that's our other answer. Okay, now to finish up quickly, just let's see if we get the same answer by using the tan thing, and it might be a bit shorter because this was quite long, right? So it might be a bit quicker to do the tan one, the tan double angle formula. I'm going to keep all of this so we can compare. And let's do it in a different color. Let's do it in blue here. So we're going to say 4 over, and then tan 2x becomes this whole thing, right? So 2 tan x over 1 minus tan squared x plus 5 equals tan x. Okay, so again, 4 over 1 divided by this, so it's just going to be 4 times 1 minus tan squared x over 2 tan x plus 5 equals tan x. Okay, so let's multiply everything by tan x. So we get 4, 1 minus tan, I'm going to multiply the 4 in so long, to save a bit of time. Okay, so multiplying 4 in here gives us 4 minus 4 tan squared x plus, and then 5 times 2 tan x is 10 tan x, and then tan x times tan x is tan squared x. Okay, so, 2 tan squared x, right? 2 tan x times tan x. Okay, let's get everything to one side. So let's say 0 equals 2 tan squared x. Oops. So 2 tan squared x plus 4 tan squared x is 6 tan squared x minus 10 tan x. And then minus 4 equals 0. Divide everything by 2 to make it a bit easier. 3 tan squared x minus 5 tan x minus 2. Okay, then again we can factorize. So we'll have 3 tan x and we'll have tan x. And we'll have a minus 2 and a plus 1. So that means either 3 tan x plus 1 equals 0, or that tan x minus 2 equals 0. So this gives us tan x equals, take the 1 over, becomes negative 1, and then divide by 3. Or tan x equals, take the negative 2 over, it becomes positive 2. Okay, so this was definitely quicker, but we see we get the same answers, right? 2 equals tan x, 2 equals tan x. Negative a third equals tan x, and negative a third equals tan x. It's the same thing, this is just a much shorter version. But if you didn't learn this formula, didn't memorize that, you can always just change everything to sin over cos and use sin over cos things. Okay, I hope that was useful. Again, if there's any comments or different methods that you guys tried in any of these questions, please let me know in the comments below. And hopefully this is useful shortly before the final exam at the end of the year here. All right.